Hello everyone, welcome back to our channel topNotch Tutorials. I am going to cover a different type of series this time in which I am going to solve Leetcode related questions. So to start off, this is the first question we are going to cover, which is valid parentheses. This is one type of question which is asked in some or the other way in interview questions for companies. So this is the basically statement in which we are going to have an input string of s which will have either of these six type of parentheses, which are basically in the form of opening and closing parentheses, and we want to determine if the string is valid or not and return true or false based on it. But there are conditions if to check if the string is valid. So the first condition is that the opening bracket must be closed by the same type of brackets. So basically our opening bracket of type this must be closed with the second character, as you can see here. An opening bracket of type curly must be closed with the same type of bracket. A opening bracket of type box must be closed with the same type of box bracket. This is the first condition. The second condition is that an opening bracket must be closed in the correct order. So a string of suppose this this is a valid string because as you can see here, the opening curly braces is the first character, like the second character, but from the closing point of view, if you see, the first character the curly braces will encounter is the opening curly bracket, and then the second character here would be closed by this one. But if had it been something like this would have been an invalid string. And the third criteria is that every closed bracket must have a corresponding opening bracket of the same type. So it cannot be something like and then something like this. So this closing bracket doesn't have a corresponding opening bracket. So if you see the examples, you can see the first one is pretty straightforward. The first character is an opening one and the second is the same type of closing parentheses. Same goes for the second example. They have all all the six characters, but they are in the correct order. A opening one is followed by a closing one. But if you see the third one, it has an opening bracket, parentheses, and then the second character is a closing one, but it's not of the same type. So it's an invalid string. So first of all, what I would understand in this is what type of data structure you must look for while solving this problem. For this problem, you would require a stack related data structure. And how did I reach that conclusion? Because for every closing bracket, whenever we encounter a closing bracket, we need to check that the one just before it is a the opening one of the same type basically. And that's why I know that I want to use a stack to keep track of which ones I encountered, and whenever I encounter a close one, I need to look at the top of that stack to understand if it's of the same type or not, or return false if it's not. My logic for that would be, first of all, I'll check if the string length is basically odd or not. If it is odd, I can directly return a false because I know that if the string is just suppose this character, or even if it's something like this is an invalid string. So straight off we can return a false, and this would be of type it would just require time complexity of O of 1 because right now we directly know that this string is invalid. The second thing I would do is basically create a stack, and I would create a stack of characters for this because I can store characters, each and every character into a stack. And what I would do is basically whenever I encounter a opening parentheses of any type, when I go and look at the string of characters and I see that there is an opening parentheses basically, so of type or this or this, I can go ahead and just insert it into a stack. right? What this would do is, when we encounter a character of type, suppose closing bracket this, what we can check is if the one on the top of our stack, which means at the end of a stack, is a matching one with the opening one of this parenthesis. So every parenthesis has its own matching one. So what we need to do is we need to check if the one we encounter right now in our string has a matching opening one or not. For suppose in our first example, the first one character, we enter that into a stack. Now our stack, for our example, our stack would look something like this. Now when we pass through the second character, we will go ahead and check the top of the stack, and the top of the stack will now have the opening one. If we see a matching opening type of parentheses on the top of our stack, we can basically just delete this character from our stack. And if the stack at the end of the string length is empty, which means that we can directly return true, because at this point we have passed through each and every character and we found that each of the closing parentheses was followed actually by a opening parenthesis of the same type, and that's why our stack is empty at that point, and that's why we can return a true state. So let's get started with it. So first step, as I was saying, first of all we will see if our s dot length mod 2 is not equal to 0, which means it's an odd one, and directly we can return a false in this case, correct? Then we will, for our second step, we can create a stack of character and just let's name it as st for simplicity, and then we create a stack. For our third step, what we will do is we will iterate through the string, but since we want to store characters into a stack, we will iterate through it using a char array, correct? And this is our char array, and now we know that the character C will always have one of the characters. What we want to do in this case is basically go through each switch case, basically just for simplicity. For a switch case, now we will check if it's matching with any of the opening ones. So if it matches any of the opening ones, what we plan to do is basically just insert it into a stack, correct? So at this point what we are doing is st.push c, and then we will break out of this. For a second case, suppose we encountered an empty a closing parenthesis. What we will do is, first of all we will check if st.pop is not equal to the following opening one, correct? What this does is, this not just checks the top of the stack, it also removes it at the same time. But while removing it, it will check if it has a matching one. So for this type of closing parentheses, we need to check this type of closing opening parentheses was present in the top of the stack or not. If it is not present, we are going to return false, and then break out of our loop. Case, and then we are going to just repeat it for other types. So I'm going to just copy this and repeat it for our other types. Okay, so for our closing curly, we want to check if we have an opening curly. And then for our closing box bracket, we also want to check if we have an opening close box bracket. Now, there is one more condition when this can be false for our closing parentheses. If we encountered a closing parentheses and if we found that at that point the stack was empty, because we don't want our stack to be empty, right? If what if the string starts with this is an invalid string, right? Because it doesn't have a following opening bracket. And if this at this point, suppose this is our basically string, and sorry, suppose this is our string, we are going through each character. We encountered first one, this case failed, we reached here. Now it's trying to do st.pop directly. It's going to throw an error because at this point the stack is empty, and this is going to cause errors. So what we are going to check is if a stack is empty at this point or not. If it is empty, we can directly return a false. And if it's not, it's going to check if the pop is matches or not. If it doesn't match, it's going to return a false. And this is what we are going to do for each type of closing brackets, correct? Because what we want to do is, this is not just for single character closing brackets invalid. What if we have something like, we have this which is correct, but then we have this, the first character got pushed into the stack, the second character we checked, it was valid, we removed that from the stack. Now our stack only has something like, now our stack is empty, and now we encountered a third character which was a closing bracket, and at this point our stack was empty and this would have been an invalid string. That's why we are checking the empty condition. And then finally, as we were discussing, at this point, after everything is done, if our stack is still empty, it's true. So instead of doing something like true and then false, we can directly write if stack is empty. I hope this helps you clear out how to solve a problem. If we try to break it down into pieces, it becomes a lot more easier. And I see that my case has failed for the second one. Let's see what failed. We entered the first character, that got pushed into the stack. For the second character, we were checking its matching opening braces. For the box one, we tried to push it. The closing one, we checked, this is what was failing. So we want a opening close bracket here, and let's try to run it again. All our cases passed, and let's submit it. So what we learned from this problem is, if we try to break it down into small pieces, it's going to be very easy to solve it. I forgot about the time and space complexity of this problem. So for time complexity, we know that this is a single line operation, this is the stack we are creating, and then we are going through each of the characters. So our maximum time would be of O of n, where n is the length of the string. And then our space complexity is also going to be of O of n type, because we'll have a stack which would have which would basically store space of O of n time in the worst case possibility. I hope you find this video useful. Comment down below if you have any questions, and don't forget to subscribe to our channel topNotch Tutorials.